All right, everybody, last review video for today. Some hints were given as to the nature of your part 2 question, and a student cleverly figured out that this would be very similar to yours. In this one, I gave you all possible pKa's, and I believe on yours that's true too. I picked a different polyprotic acid in the middle, but it's the same idea, okay? Just use my numbers. This one, you don't have to come up with any numbers. They're all here. Okay, step 1, and I'll do it in the right order this time. Step 0, actually. What is step 0? Get rid of all the spectators. Now you can tell me which of those 2 species has the extra proton. The one on the left or the one on the right? Left. What's its pKa? Trust me, it's not 3.1. Not when you have a crossed off O minus. That means the H is missing, right? The 3.1 is gone. .8. It's the only one gone, right? And thank you, sir. And we've got, therefore, this molecule is that's an acid. Therefore, base. Okay. Oh boy. Okay, so we got a base. We have a tripeptide and 4 pKa's given. How many are missing? I have a tripeptide, that means 3 protons, out of a molecule that could have started with, at most, 4. How many are missing? Oh, it's diprotonated. I had tri in my brain. Sorry, was that my previous example? I don't know. I apologize. She was saying the right answer over and over, patiently waiting for me to catch up. Yeah. So, you gotta read that. You gotta read this. That means 4 possible. Means last of 4 pKa's, right? There's the 4. Okay, diprotonated 2 pKa's. Just going slower because clearly I'm having trouble. There we go. Missing. Missing. Now you're down to 2, right? Diprotonated, right? Can we pretend we watched the last video and realize the last one that comes off is the first where you got to put the proton? First one back on is what I was going to say. Instead of calculating all those pKb's and realizing it was the last one off that became the first one on, we proved that last video. Let's take advantage and save time. So it says when there's a proton on the sp2 nitrogen, the pKa will be 6.1. I'm just reading this. When there's a proton here, its pKa is 6.1. Where is it? The cyclic sp2 nitrogen. There's only one. This is not in a ring, this sp2 nitrogen. This is. Don't talk to me about that. That's sp3. Don't forget, lone pair. Right? Lone pair. So this one that must be the acyclic. Yeah. So before it was missing, it was here. Okay. And then we got, that's the 6.1, right? And what you're going to do, I mean, it's hard to circle. I would at least draw the ring. And I'm going to use a different color. Remember, You can't just write this. You can't just do this. Don't forget that charge. That's the number 2 mistake. Students forget to put the H plus on. They just put an H on. They forget that acid-base chemistry is about protons that have a charge. So the charge changes every time you put a proton on or take it off. Now you define R properly. Everything up to that ring, but not including that ring. Equals R. Now you got your 2 out of 2. Saves a lot of time, doesn't it? Okay. pKeq. Oh, what's the pKa of this thing? I wrote it on the left. No, I don't need pKb's. You do need the pKb here, though, since you're on the topic. Yeah, 14 minus 6.1 equals 7.9. And I'll use an eraser. That's part of my answer, so it's in a highlighter. Okay, other pKb, since we're on the topic. What's the pKb here? 14 minus 4.8. I can tell you guys been studying. That's good. 9.2. 10.2. No, 9.2. 9.2. Right? Yeah. Add them up. See if it's 14. Yeah. pKa's, pKb's, connected pairs, pKeq's. Left acid, 4.8. Right acid, 6.1. Negative 1.3, right? How do you know you're circling this arrow? Yeah, 4.8 is more reactive. We go away from that. 6.1, less reactive. We go towards that. Smaller, bigger arrow that points that way. What about KEQ? Yeah, verifies what you just circled, doesn't it? I have more than 10 times as much product as reactants. That's what that says. Probably 30. I don't know. We'd have to ask Dr. Yackel to come out of retirement, and he would tell you, within 5% error, what 10 to the power of 1.3 was. He could do it. He's done it so long. He's good with numbers. I have no idea. My guess is 40. I might be way off. Anybody got a calculator? I'm curious. Now it's bothering me. Did we finish the question? Yes, sir.
So for the first citric acid, you reiterate how you know that pKa 4.8?
No, you have to know that there's an H missing up here. Yeah, and there's 4 H's possible. 1, 2, if put the H there is 3, and the H here is 4. That's 4. So I gave you all of them.
So since there's one missing, you cross the first well.
Well, if you've got a spectator ion, it took the place of an H plus, right? K plus takes the place of H plus, right?
So there's 3 H's, how come it wouldn't be?
Oh, if this thing started with a real citric acid, this is the real citric acid, fully protonated. What's the pKa of that? pKa is 3.1. But that's not in this question, is it? And that's all.